Welcome to today's webinar. We're going to talk a little bit about mainframe data, how you can make it more governed, compliant, and cloud ready. Today, I have Vince Ray with me. He's one of our co-founders and CTO. I am Dustin Froyum, and I am one of the co-founders and focus on our partnerships. So I think it's pretty well established. Most industries have increasing regulatory pressure. I know I spent 20 plus years in financial services, and it was just a continuing escalation, more regulations, more legislation that was passed that was always putting pressure on us. And we spent a lot of time and effort on compliance. And I think that's generally a theme across many industries today. And so how do you integrate your mainframe data to the cloud and to distributed systems while still making it compliant, audit ready, and actually increasing some of your control and security of that data? Often case data remains very siloed, especially on the mainframe. And that's one of our key things that we have set out to address from the VirtualZ perspective is how do we make that data really on par with any other open system data. And so how do you share that, access it, while still maintaining a lot of your security and controls? And then we're going to talk a little bit about access to data as well. So if you need to merge that data quickly, easily in a no-code fashion, how do you keep that audit ready or regulatory examination ready in an easy, controlled way? So like we mentioned, I'm not going to spend a lot of time on this, but anyone that's dealing in the mainframe space knows that integration to the cloud can be very challenging still, or even in distributed systems. And many of these are homegrown solutions around, kind of classic ETL or change data capture. And there's commercial products out there as well, but many of them are pretty complex. Still and extremely costly. And so we'll address how we tackle that from a VirtualZ standpoint. And again, not going to spend a lot of time on this, but I think this is pretty well known in the Z space, right? You have escalating costs, talent shortages, again, legacy complex, or even commercial complex integrations. And then, how do you serve the needs for AI and BI and modernization at the same time? So those are distinct challenges in this space that we're here to help solve. So today we have 3 products, all dealing with mainframe data integration. And I'm not going to spend a lot of time on this slide because we're going to dive a little deeper into these and just how they apply to compliance. But these are the 3 products, and you can kind of see the summary here, but we'll get into it a little bit deeper about how these differ and how each one of them works. So Vince, you and I both have been around the mainframe for quite a while, different capacities. I spent a lot of time in third-party risk management. Obviously, you as a technologist. So let's just talk a little bit about some of these challenges and how our solutions address them. So overexposed access, and I know that was one of your concerns, right? Especially having a background in mainframe data security as well, as the author of Top Secret. Can you just talk a little bit about your approach to this and the VirtualZ products?
Yeah, well, I mean, the way this originally came to us is that I think customers were loud and clear. They know how to secure their data on the mainframe. They have, wonderful tools there, security products, all sorts of things there to do that. But in today's day and age, that data is needed on lots of other platforms. And, one of the things that, we've heard pretty clearly is that a lot of the mainframe folks get awfully nervous when step one is take your nice secure mainframe data and put it on another platform someplace, and suddenly you're relying on that other platform to keep it secure. And that other platform might be, I don't know, sitting in the cloud. It might be, God knows what database. It might be, who knows what it is and who knows how secure it is. So, certainly one thing that we like is the idea of keep the data on ZOS, where in order to access it, you have to go through ZOS security, and that's a huge thing. And sometimes it's not just about keeping the bad guys out. Sometimes it's about some of the other things that you've mentioned here. How do I audit who accessed the data and when, and what do they do with it, and all of that stuff. Again, another example where everybody knows how to do that on mainframe. Not too many feel 100% confident about how they do that sort of thing on other platforms. So keep the data in a secure place is definite, and minimize the number of copies of that data is definitely an important part of the strategy here.
Okay, thanks. And then Vince, let's a little bit of audit trails, right? So one of the challenges we've solved is unified access to mainframe um, like management data, SMF data, console messages. Can you just talk a little bit about how we solve that and what we do there?
Yeah, I mean, and honestly, there are two sides of that. I mean, the first side of it is, just to use an example from our Lozen product, if you access mainframe data, you'd like to know that there's going to be an audit trail of it. It's not like I just, made a copy, stuck it somewhere. Now I have no idea who's doing what with that data. With products like Lozen, uh, you still go through ZOS security, you go through ZOS SMF recording, you go through all of the normal layers there for ensuring that there's management. So that guarantees us that the audit trail you want is actually produced in the first place. The second part of that is what you said. What can we do to make that data more accessible and easier to consume? I mean, the truth is there's a huge amount of management information on your mainframe, but sometimes it's not the easiest thing in the world to consume. Those SMF records are complicated, they're hard to access, a lot of really expensive software designed to help you understand that. So, one of the things that we built into, it's actually a few of our products, is the ability to, number one, just centralize that data. So it's not the case, you have data centers in 3 cities around the world, and they all run multiple LPARs. I mean, just knowing where that data is could be a challenge. So, we can help you centralize all that data, so you end up with one whatever database that has all of your management information. That alone makes it much easier to process. And we can also do things like convert it to database formats. So instead of doing these kind of complicated, where's my data, how do I read it, how do I interpret it, that becomes basically a SQL query. So all of a sudden, you can start using more powerful tools against that data, and it opens it to a lot of different insights. You could imagine, and I'll just add this as kind of a third dimension, is kind of the timeliness of that data. A lot of the approaches that do similar things to what we do work on kind of a batch mentality. In other words, you collect a day's worth of SMF data, then you analyze it. What we do is real time. So, application comes along and opens a file, let's say. The security that comes out of that, the SMF recording that comes out of that, fraction of a second after the task happens, it's in that integrated storage that I'm describing. So you could actually use that for real-time management decisions, I don't know, intrusion detection, or those kinds of applications where that's been pretty difficult before. And of course, once you get to that point, uh, especially in large enterprises, there are other, common products being used on other platforms. Splunk comes to mind. There are a lot of folks use Splunk to consolidate this kind of
Mhm.
management information. It's just never really been easy to get ZOS data into it. We make that happen. We have, and I'd invite folks to look at the demo we did of this. There's a YouTube video where we take our ZOS console message traffic and populate that in real time into a Splunk environment where you can do all sorts of analytics and AI and everything else against it to try and make sense out of what's going on your mainframe. And, more importantly, to catch those anomalies that might indicate, whatever service outages or intrusions or, all sorts of other problems. It's a big, once that data becomes accessible, it's a definite big step to, apply some of these creative analytics to it, and get a lot more value than you might be getting today from it.
Yeah, thanks, Vince. And I'll kind of talk. You mentioned a little bit about the delayed access, and I'll talk about these next two kind of in that context as well as a couple others, right? Um, when you're looking at implementing manual processes, and especially when you're dealing with regulators in particular, right? Being delayed has some pretty dire consequences in being able to respond or provide, and one that creates a lack of confidence by those regulators, and two, if you miss deadlines, there's real impact to that. So you know having access to the data in a unified platform, um, not having manual processes or waiting for, oh, I got to go to the mainframe data team or reporting team, or I have to go, if you have to go to multiple different teams to get a particular piece of data, as well as delayed access, like waiting for a batch cycle to go through, right? That's not going to work for intrusion detection and other alerting that you need to do, and being able to do that in a single pane of glass, that has a really particular benefit. So Vince, the other one I want to talk a little bit about, and this is a really hot topic, and how do you do backups and recovery for malware and application data backup and recovery, especially in the mainframe environment where, if you're using traditional tape and DASD, you have to have processing capability at a tertiary or quaternary site. So Vince, you want to talk a little bit about our capabilities there, and how we can reduce costs and increase security?
Yeah, I mean, and this is a really important point. One of the benefits of centralizing the information we're talking about to the cloud is it's accessible to you in multiple locations, really without having to move it anywhere. Just an example of that. If you got I don't know, a data center, and there's, let's say something horrible happens and there's, I don't know, terrorist activity, and your data center is offline for whatever reason, all of the data that was housed there, and that very well could include, some of your backups. It could include, of course, the live data. All of that stuff is hard to get access to. Even if you've got a, disaster location sitting there, now you got this big issue of how do I get to that data? And again, it's often the case that it's not just mainframe data you're dealing with. It's to really, you think about a modern business service that you're offering to a customer, partner, or whatever it is. It might be multiple tiers that work together to offer that service, and some may be affected, others not. They might all be affected, and now I don't just have this problem of how do I get to the mainframe data that I might not have easy access to? Now I have this problem of I need data for a lot of platforms, or potentially. So, because we leverage uh, protection in a lot of new and kind of novel ways, this gets to be a whole lot easier problem. Just one example, our ZAC product, allows you to write, what you think is local data on your mainframe, but it's really going to a cloud provider. One of the cool things we can do there is that data could be duplexed. So I might, let's say I choose, I don't know, Amazon, AWS as my primary location for that data. Nothing stops me from having a copy on Amazon and a concurrent copy on Azure and a concurrent copy in Google, and maybe a local copy sitting on a hardware device in some remote office that I have. I mean, all of that could be done really in parallel. And really the best thing about it is that, assuming you have basic connectivity, you can get to that data anywhere. I don't have to think about, in the old days, we used to talk about, that, getting those tapes from Iron Mountain and putting them on an airplane, and it might take you, you know, 12 to 24 hours just to get the data where it needs to go. That totally goes away. And, and yes, there are other ways of doing that in modern times. But, this is really the only way to do what we're talking about, that embraces mainframe data just as it would any other type of data. So, getting to all of that data wherever you are makes for a really good defense against some of the attacks that we've seen. And that's really the other side of the story here, is that, as a, I think if you were to interview a lot of data security experts, one of the common themes you would hear is that your best defense is often lots of copies of your data, so that it's not just, if I can corrupt your backups that are sitting on that virtual tape library, I can hold you hostage. I might have that, but I might also have, several other copies of the data in other locations that are each challenging to get to. So, when you're thinking about kind of all the evil things that can happen in the world, having multiple copies of your data in different locations in a way that you can access it all nearly in real time. I mean, that's a huge advantage. And by the way, that's true for not just the actual data, but for what we were talking about before, management data. Sometimes, and I probably should mention this before, that management data is like a crown jewel to a lot of locations. If you need it in even in, forget data protection, ransomware, that kind of stuff. I mean, you just might have a legal situation where you need to prove what happened on your systems 2 years ago, or whatever it is. That management data is your answer to that. So somebody were able to corrupt it or delete it, or do something to it, that certainly becomes a really big risk. And again, one of your best protections is just to make sure that you have multiple copies of it stashed away. And of course, you don't want to do multiple copies at insane cost of doing it. You want to be able to leverage, whatever it is, Amazon Glacier, or whatever low cost storage you might find out there. And that of course makes it much easier to do the things that I'm talking about. If it's millions of dollars per copy, that gets to be hard to justify. And in the next round of cost cutting, that's going to be one of the first things to go in a lot of sites. So it's kind of the best of all worlds here. You get copies of your critical information, and it's inexpensive. So yeah, it's a win all the way around, and that's something we think kind of changes the picture here quite a bit.
Yeah, Vince, I know we're coming across many customers that have, they're kind of looking at their overall data center structure, one to increase their availability, but also to reduce costs. So, one comes to mind where they've gone to, they're toggling between two primary sites, but now they don't have really a true backup site. And so, the choice for them is, oh, do they go to a third geographically diverse, different place on the grid, put some more mainframe frames in there, DASD, tape, etc., into those sites? Um, or do they do this really in a software defined way with Zach or Propels in a much, much more cost effective model? They don't have the data set, that third data center space. They don't have the frames, the physical hardware, power, cool, any of that stuff, right? And they have the same level of security from a tertiary or quaternary. Plus, Vince, we didn't really even talk about, being able to, use some of the immutability and the multiple copy capability right within a particular cloud, let alone the duplexing capabilities we have too. So that's a pretty powerful story and a very cost effective one as well. So Vince, let's dive just a little bit deeper into the specific products, how they work, and I think a little bit of the use cases will come out of those as well. So let's just briefly talk about Propels, even though we've kind of touched on some of those use cases. But how does Propels work, and where do these use cases come up with Propels?
Yeah, well, Propels is really simple to understand. It's ZOS utility that we provide that can take pretty much any mainframe data and push it to just about any target. Typically, the target's going to be a database of some sort, and out of the box, we provide connectivity to pretty much any database that supports JDBC. So there's probably 100 targets there. We also have the ability to insert, I'm going to call it customized pushes of that data. I mentioned that we have the ability to take things like console message traffic from ZOS and push it into Splunk. Well, that's basically an API model. We're not, sending that through JDBC. We're communicating with the Splunk API directly. So Propels is kind of like that. You start out with, whatever data you want, and typically the data is going to be things like vsam files or various types of file system objects on your mainframe. But honestly, it's open. It's possible with Propels to uh, work with nearly any kind of data. It could be the output of a program. It could be, I use the example of console message traffic a minute ago. That's not a vsam file or any type of file. That's kind of an API on the input side. So, very open on the type of data that can come in and the type of data that can go out. Uh, in between, the strength of what Propels does is, if you want a bit for bit copy of the record that you start with, you can do that. But, frequently those mainframe data formats are complicated and not easy to understand. So we have the ability to do transformation of that. So if I want to take, let's say a vsam file record, uh, supply a little bit of metadata that tells us about the layout of that record, we could transform that. I use one example, rows and columns in a database, but it could also be, JSON objects or XML objects or CSV files, really just about anything that you want can be done in Propels. And then the other really cool thing that we can do with Propels is it can be done either as kind of a one-shot thing, or it can be done incrementally. So I could take let's say I have I don't know, a vsam file that's being updated periodically. Well, I could set up Propels to kind of monitor that file for changes. And then as it sees changes, to keep the targets synchronized with them so those incremental updates happen. And really uniquely in our space in the industry, we do that in an asynchronous way. So it's not like, my application that's updating that file needs to kind of wait for that, replication to happen. It does whatever it wants to do, propels, figures out, moments later or minutes later, depends what your needs are, that changes occurred, and then we, resynchronize everything. So, a lot of the customers we speak to struggle with change data capture approaches where typically you're doing updates kind of in line with the data changing, and you need all sorts of journaling and logging and all sorts of other things, as well as lots of network bandwidth. Propels needs none of that. Mainly, we find a lot of folks really don't have that use case where they would require it. A lot of times what they're doing is replicating that data so they can do analytics or AI or, something else on it. And it's not really the case that it needs to be, updated with complete integrity in terms of, the original VSAM file is updated and the target's updated. Most folks we speak to are fine if that's, I don't know, 5 seconds later or 3 seconds later or whatever it is. And it frees you from all of that infrastructure you typically have with change data capture. So Propels a lot of things. And Dusty, I apologize. I don't mean to ramble on.
No, that's good information. I'll just tell one anecdotal story about, and Vince, this, right? We have several customers that are one of the key use cases for Propels is migrating tape data to modern platforms, either again extracted into a database or just stored as a blob. And so kind of an ultimate compliance story, which is um, there was a company testifying before Congress, had to do the typical, oh, I'll have to look into that and we'll reply in writing. Well, they went back to get the data and the physical tape had degraded. And so, they had to come back and report back to Congress that they no longer had access to that data. And so we have a lot of those projects going where folks are looking to use Propels to migrate that, particularly off physical tape media, but it doesn't just have to be physical tape media, tape data, either because they're retiring their mainframe or they just want to get to a more modern storage solution, and take advantage of some of that duplexing or multiplexing that Vince relayed. All right, so let's move on here. So let's talk a little bit about Lozen specifically and why this is kind of the ultimate control and security for your data from a mainframe system of record standpoint. So Vince, you want to talk a little bit about what Lozen is and why Lozen exists, and how it gives you the ultimate control of your mainframe data?
Yeah, I mean, we touched on Lozen earlier. Lozen is the case where you can put your applications wherever you want to, in the cloud, on some other platform, whatever you want to. But with Lozen, the data stays where it is on the mainframe. And this is important for a lot of reasons. Probably the biggest reason is that a lot of times when you look at replatforming mainframe applications, one of the issues is that there are a lot of data dependencies. It's not like you only run one application on your mainframe, and it's not like your applications each have different sets of data. Quite commonly, you have one set of data that's banged away against by a handful of applications. So you just want to move one of those applications. You get this really big problem of what do I do with the data? If I move the data, I'm breaking the applications that I'm not moving off the mainframe. And if I have to move all the applications, suddenly this gets to be a risky kind of big bang approach that can take a long time, not have great paybacks, and yeah, and the proof is in just what people do. It's why a lot of applications just never migrated, even when they make a lot of sense to run on other platforms. So Lawson kind of breaks all of those issues apart. What we do is we let you keep the data on the mainframe, so all those other applications that still need access can continue to reference the data, but suddenly you have data access no matter where you need it. So if I want to bring an application to, somebody's cloud platform, I can take just that one application. It gets access to same data it had when it was native Z application, but it doesn't impact all the other applications that might be going on there. From a integrity and compliance point of view, we do this, with full security and integrity on the data. The data is, encrypted in flight. It might be encrypted at rest on the mainframe, depending on what you're doing today. All of the options you have today continue to work. And the access to that data happens with the very same user credentials that you might have had on when you had a native application running on Z. So I move that application, suddenly I'm not giving it any different access than it ever had. It still runs with the same credentials. That means it's subject to the same security policies. That means you can get that audit trail. You're going to see in the SMF records and so forth who the user was, how they accessed the data, and so forth. The only difference is they're doing this access on some other platform. And maybe best of all about this is that this isn't a dumbing down of your system. If I got, let's say a VSAM file, there are, I don't know, 40 things you can do to a VSAM file. Search for records by their keys, read the file backwards, insert and delete records from the middle of, all of that is fully supported with Lawson. So there's no loss of functionality from a data access point of view. You have all the same capabilities you would have if you were writing a native application. They're just accessible to you from anywhere. So that's really the strength of Lawson. That the data stays where it is, still managed the way you've always managed it. There's only one copy of the data, so you don't have that problem I described where suddenly you've got hundreds of copies of your data spreading around your network. So it lets you stay in control, very high performance, and all of the management that you would think of doing with that data stays the same. You don't have to invent some new way of managing your data when you're dealing with distributed applications here. So that's kind of the Lawson paradigm, and I want to be really clear. If you start out with files on your mainframe, the paradigm is file based. So open, close, read, write. As I said, same thing you would do on ZOS to get to this data, you're going to do on other platforms. So no application changes needed. If you got business logic in your applications that do all sorts of weird things with VSAM, that continues to work unchanged. And of course, you also get the benefits of the data transformation that I described. If you want us to take that mainframe data and transform it in such a way that it becomes a JSON object, for instance, to the target application, we can do that for you too. So
All right.
I'll try not to go too much deeper.
No, yeah, there's deep dive webinars on each one of these and blogs on each one of these products. So if there's questions, we'll be glad to do that in a live briefing as well. So I think that's a perfect survey. So let's move on to Zach, Vince, and maybe one thing to just touch on when we talk a little bit about Zach is just our overall architecture. There's kind of a consistent architecture with every one of our products. They're all mainframe based, and then zero code on the cloud or distributed side. So make that goes to one, the power of utilizing kind of the native mainframe functions, but still with the ease of implementation and no code as well. So yeah, that's consistent across all three of these products. So Vince, on Zach, and I, we've touched a little bit on some of the use cases with Zach, but maybe just a little bit more what makes Zach unique and really the power of Zach.
Yeah, so honestly, this is something I'm sure everyone who views the session here is familiar with. If you forget the mainframe for a minute, for probably the last decade, there's been a lot of options where if you need more storage than is on your local system, you can use whatever cloud you want, and it's implemented in different ways. Often it's a file system driver for Linux or Windows. And what you do is you connect some, let's say Amazon S3 storage to your Windows server, or whatever you got. And suddenly you can have almost an unlimited amount of storage at very, very low cost with no real change. It just looks like local storage to you. Problem we saw is that mainframes never really participated in that, mostly because mainframe's kind of a weird and very unique I/O architecture. So the way to think about Zach at a high level is that's what we've done. We've created a system where we can give you what amounts to a virtual disk on your mainframe that's backed by cloud storage, or even by physical storage if you have maybe a SAN in your environment that you want to use for mainframe data. The beauty of this is your applications just see another device. They just see another standard mainframe disk, and they're free to do whatever they could otherwise do. It's not just sequential files. They want to create a vSAM file on that cloud storage, or a DB2 database, or maybe you've got a vendor product that's doing low-level primitive I/O. All of that's fully supported, against a virtual disk. And what Zach is doing is capturing the I/O requests to that virtual disk and transforming them into whatever the target can supply. And this is one of the other breakthroughs with Zach. We've done that in I'm going to call it a standards-based open way. So, if a customer tells us, what, I want to use your virtual disk model, but I want to go to Dropbox, for instance. It's not like we have to go write mountains of code to do that. We take the uh, Dropbox file system drivers that are available in the open source community for Linux and other platforms. We make them run on the mainframe, which is a pretty simple port. And now all of a sudden we support Dropbox as equally to any other platform. And, plug in the blank there, we can connect to just about anything, and you don't even need to be dependent on us for that. It's a standard that we publish and document. So, if you had a good reason to do it, you wanted to sit down and write your own, you absolutely could write your own. So, very open in terms of what we can support. And you see that today. We have, certainly Amazon, Azure, and Google. We have things like iSCSI network hardware devices, SAN environments that we support. We have examples of various types of cloud applications, like GitHub is one we talk about. Sometimes we can take source code that you've got in GitHub and make it look just like a local disk and local file on your mainframe. So very flexible, and of course you can have as many or as few of these as you want. If you just need, I don't know, maybe you got a new version of an application, you need to test it, you need a few terabytes of data tomorrow, and you just need it for a week, by all means you can do that. Spin up whatever you want, your favorite cloud provider, define that to Zach, and literally seconds later, you're able to leverage that storage. And probably just as importantly, when you're done, you're able to take it down and stop paying for it. So it becomes a very dynamic, on-demand, agile model that lets you kind of adapt to changing storage needs as you go. And I'll mention also, I mean, I've been using virtual disk, but technically we also support virtual tapes. So if you wanted to do all the same things I'm talking about, but think in terms of virtual tape, that's possible too. So, and it's all in one product. It's it's bi-directional. It's all the same attributes we talked about before. So if I wanted to create this library of ZAC virtual disk or tape volumes from one data center, and then for whatever reason something happens and I need to access that data somewhere else, nothing has to be restored. There's nothing, assuming you have the security and credentials that allow you to access that data, you can access it anywhere, with no impact whatsoever. And again, one of the things I guess we're proud of in this is that we've also developed a number of patented technologies around the way we do journaling and caching and some of that kind of thing. And it's really 2 points. One, obviously, it's a performance point. When we do writes, often a write to a cloud is a slow thing to do. You've got to wait for the data to get transmitted, and you've got to wait for the cloud provider to process it. In our case, we have the ability to do local journaling on ZOS, so that we can make all of those writes completely asynchronous from an application point of view. You have an application that writes a block of data, comes to Zach journals it, and as soon as the journal is captured, we can consider that IO complete. There's no need to wait for the communication to the cloud. And what that does is, so in addition to better performance, that also gives us network resiliency. So if I have, let's say it's a momentary hiccup in my TCP/IP network, and I lose connectivity to that cloud provider or the SAN device or whatever it happens to be, there's no operational impact to that. Our journaling system handles that, so that when that connection comes back online, maybe 20 seconds later, we just pick up right where we left off. There's no loss of data. There's no loss of data integrity. Everything just continues, and it makes the entire environment much more resilient that way. So, lots of other features. I won't take your time with, Dusty smiling. So yeah, it's but you know what? I love doing these presentations, and I love doing these one-on-one, and I look forward to the really hard questions that customers sometimes ask. So by all means, if you want to learn more, just I'm just kind of scratching the surface here. So give us a shout.
Yeah, I can attest to that. You like the hard questions, Vince. So it's fun to have those discussions. Yeah, I was just gonna, I was really smiling because I just like flashbacks to all these discussions about, recovery time objectives and recovery point objectives, and Zach with essentially, covering the recovery time objective, really bringing that down, you know, because of the ethereal nature and the virtual nature of your data, right? And having it in several locations that you could recover from, almost instantaneously, unless it was something just unimaginably catastrophic, right? And then, with the journaling function of Zach, being able to talk about a 0 second recovery point to objective as well. That's just, those are great things from a compliance standpoint that you can highlight using our products. Okay, I'm gonna go to kind of a summary slide. And I did, one topic I wanted to ask about, Vince, is um, we talked about control of data, particularly Lozen, but in the ETL context, you are creating a copy of the data. And so one of the things that comes up pretty frequently for us is, can you mask it? Can you do data exclusion? Particularly in Propels when you're actually, you are potentially moving that data. So Vince, can you just briefly talk to that piece in our kind of our summary here?
Yeah, and that's a great point. I mean, sometimes you have these files with, gazillions of columns, and some of them are super sensitive, social security numbers or, you know, financials or, whatever the data happens to be.
HIPAA
So
data, right? We have lots of
yeah,
healthcare, right?
yeah, healthcare, it could be, I mean, all sorts of things.
Yeah.
So, one of the things that we can do in the data transformation that I described is it's not an all or nothing thing. So I could define a little bit of metadata that says, when you look at this file, it might have 100 columns, but I just want 3 of those columns sent to the target. And then the target database might be, whatever you want it to be, some subset of those columns. They're never even transmitted to the target in that case. You can also do uh, selective encryption that way. I mean, some people might say, you know what, I want the data, but I want to make sure that only authorized people could read it. So I might take your social security number, for instance, and replace it with an encryption of your social security number, and only somebody who knows, the proper keys and so forth will be able to process it. So a lot of flexibility in that dimension. And of course, when we communicate to that target database, that all of that communication can be protected as well. It can be, certainly it depends on what the target database supports, but virtually all the modern databases support encrypted networking. And, we're able to take advantage of, any of those things. And by the way, just as importantly, sometimes you don't want to take advantage of those things. We talk to some customers that have huge investments in, let's say VPN technology. And the last thing they want to do is pay the price of encryption for at the network level using VPN, and then also encrypt the application data. I mean, that's just kind of double the overhead. Sometimes you want to do that, and find that we can do that, but sometimes you're confident in your, the security of your network, and you say, I want to also be able to operate, without that, and I'll rely on my network to give me the secure communications I need. So complete flexibility there. And, in most environments, like, we talked about Lozen, it's not even a all or nothing from what protocol do you use. Lozen can use, Kerberos and GSS encryption. It can use TLS. It can use, I mean, there are like 4 or 5 that we can fully support there. So, and, I think another common thread in really all of our products is the kind of controls we're talking about are on a connection by connection basis. So I might have, I don't know, let's say I run an application in a trusted server that's sitting in my own data center 20 feet away from my mainframe. Maybe I think about encryption and security differently in that environment than when I'm communicating to, an application that's sitting in the cloud, for instance, or, on a user's mobile device. And, we support all of that. You can have, much tighter encryption for that mobile app that needs to access mainframe data versus, something that might go on right in your own data center. That's kind of part of it here.
Thanks for adding that piece in, Vince, because I did want to make sure we covered that, in particular in the context of Propels, where it is an ETL solution. So Okay, well, thank you for joining us today. If you'd like a deeper dive into any one of these solutions, products, our approach on things, feel free to register or reach out to us, not register, reach out to us at hello@virtualzcomputing.com. Also at our website, there's tons of resources. Vince mentioned the demos. There's demos of each one of these products, and then they do have compliance type applicability that you can kind of see through those demos, blogs on just about any topic or question. And this our podcast, so we have some great previous guests. That podcast is called Skyward Data, can be found on any of your podcast platforms. We all our webinars are on podcasts as well. So if there's one of these deeper dives that you want to listen to instead of sit and watch a video, that's available on our Skyward Data podcast channel as well. All right, thanks, Vince. Really appreciate it, and I hope everyone will join us for the next one. Thank
Yep,
you.
thanks, Dusty.